Welcome to our week number 2 lecture. In this lecture, we'll be concluding chapter 1, so we'll go through sections 1.3 through 1.5. Section 1.3 is called deduction and induction. So deductive arguments incorporate the claim that it is impossible for the conclusion to be false if the premises are true. And this is how most people operate, right? They have some true premises that support their conclusion, and therefore the conclusion can't possibly be wrong because all of their premises are true. Inductive arguments claim that it is improbable that the conclusion is false if the premises are true. So inductive arguments take into consideration that it is possible to have a false conclusion even if you have all true premises. Now it's not probable, but is improbable, so there isn't that big of a chance. So let's start and go through. So deductive arguments. Conclusions follow necessarily from the premises with 100% certainty. Indicator words, certainly, absolutely, definitely. Types of deductive arguments that you see are going to be things like mathematics, like when you do proofs in math. Arguments from definitions, categorical syllogisms. We haven't talked about syllogisms yet, but we will talk about syllogisms later. So there's some different types of syllogisms that also are deductive arguments. Deductive arguments forms. There are specific forms for those arguments based in mathematics, arguments from definition, and again, that syllogism. And this is just, a syllogism is just an argument that consists of exactly two premises and one conclusion. And you're going to see patterns in these, you're going to see all kinds of cool stuff. So we're going to talk a lot about syllogisms later, but they have a very specific pattern. All right, so a categorical syllogism is a set of three statements where it places objects or persons into categories or groups. And it's going to use words like all, none, or some, no, right, those kind of words. So here are two examples here. All cats are mammals. All mammals are animals. Therefore, all cats are animals. So very simple. You could go from cats are mammals, mammals are animals, therefore cats are animals. Very simple. Some fish are not trees, and no trees are plants. Therefore, some fish are not plants. Okay, nonsensical, but it follows the pattern where you have two premises that are true, and then you'll have a conclusion. You have hypothetical syllogisms, or these if-thans, hypotheticals, where they're paired with other if-thans, or they're paired with another statement of some sort. So like this first one, I won't read both of them because I know you guys can read. The first one, if I receive a paycheck this week, then I should be able to pay the bills. I am now telling you I have received a paycheck this week. Therefore, what's the conclusion? Then I should be able to pay the bills. So very simple, two statements, one conclusion. Disjunctive syllogisms is an either blank or blank statement paired with other statements, where one of the alternatives will be eliminated and you're going to be left with that remaining alternative. So the pattern would be either we pay rent or we will be evicted. We did not pay the rent. So what's the logical conclusion? We'll be evicted. Exact same thing. Okay, got a nice either or. We get a statement of fact, which leads us to our conclusion. Whoops, too fast. An inductive argument, however, is when the conclusion follows from the premises with a 51% chance or better. So it's indicator words would be improbable, plausible, implausible, likely, unlikely, reasonable. Okay, those things, they aren't truths, right? They're sometimes they're opinions, sometimes it's just saying this is just a statement that, the statistical probability is this, that kind of thing. So there are things, these are all types of inductive arguments. Predictions, where you can make predictions about the future based on the past. Arguments from analogy, and that depends a lot on the existence of that similarity between the two things that you're talking about. Inductive generalizations are where you have a knowledge of a selected sample, and then you make a claim about the whole group based on that sample. So you might use, in that kind of situation, you might use what's called a particular statement, and that statement makes a claim about one or more particular members of a class. And then, or it might be a general statement where you're just making a statement about all the members of that class. So we got to be careful about making those generalizations about all of them. It's very easy to make a statement based on particular members that we have proof of, but when you just make all, be careful when you say all. That's a very hard word to prove. Other types of inductive arguments would be arguments from authority, where just because someone has a PhD, we assume that they're, just because someone is the head of the National Institutes of Health, does that mean they can't be wrong about an issue, a medical issue? Okay, be careful. Just because they are an authority does not mean that they are telling you the truth. Arguments based on signs. So knowledge of a sign about a thing or a situation, and what that sign symbolizes. You see that a lot. A lot of people believe in signs. Casual inferences, where you're just saying that we know that the cause of the claim about an effect or the converse, maybe it's not. Maybe that we know the effect it doesn't have. So things like that, those are all types of inductive arguments where we don't know 100% it's going to happen, but we know based on past experiences and that kind of thing. So here's some factors that can help you decide between inductive and inductive and deductive. So please press pause and read through those. All right, so let's try an example. Okay, so here's an example. Please press pause and tell me if this is going to be inductive or deductive. All right, and the answer is, it's inductive. And that was based on an argument based on signs. All right, and again, another example. Press pause when you see this one and let me know if it's inductive or deductive. All right, and the answer is deductive. This one, conclusion necessarily. It definitely follows from that premise. And again, if you're having a hard time finding the conclusions, maybe go back to section 1.2 and 1.1 and review that. Because sometimes if you don't know what the conclusion is from the passage, it's going to be hard to answer whether these are inductive or deductive. Right, another example, press pause. All right, and the answer is inductive. That is a generalization. All right, so just some cautions or notes when you read this section of the book. Geometric arguments are always deductive. I know that you probably did geometric proofs when you were in high school. Those are deductive. We have rules and theorems and things that we can use to prove each step of the way. Most of the scientific arguments that you do if you do hard sciences are deductive. Now, if you work in something like psychology, that might be more inductive, but most of your scientific arguments are going to be deductive, but you will have some that will be inductive as well. Common definition for distinguishing between a deductive and an inductive argument does not hold. There's no 100% here. That's what I'm trying to say in a weird roundabout sort of way. All right, section 1.4. That's called validity, truth, soundness, strength, and cogency. So the first thing we're going to talk about is valid or invalid deductive arguments. Okay, a valid deductive arguments are arguments for which it is impossible for the conclusion to be false if all the premises are true. An invalid deductive argument is where it is possible for the conclusion to be false, given all the premises are true. So you're going to have two different forms, valid and invalid. So when it comes to valid argument, there's no middle ground. Either it's valid or it's not. No gray area here. You're going to find there's not a lot of gray area in logic. Validity is not determined by the truth or the falsity of the premises. Validity is not determined by the relationship between the premises and the conclusion. Okay, that's not what validity means. Okay, you're going to hear the word sound argument as well. Sound arguments are when all your premises are true and your conclusion is true. There is only one kind of sound argument. This is it. Soundness means that you have validity, right? The form is correct, plus, the deductive form is correct, plus all true premises. So sound argument equals valid argument plus true premises. It's important that we note that not all invalid arguments are unsound. You can have a sound argument that is invalid. Very possible. Again, I'm going to use Twitter as an example because I see these a lot. So in your book, there's this nice little chart. And if you want to just press pause, you can just read through this, which gives you some nice examples of when you have true premises, true conclusions, some that are valid, some that are invalid. And then if there's none that exist for that little section, so like here, if you'll note on the chart, none exists. So you cannot have true premises and a false conclusion if it's valid. That would definitely be invalid. Okay, so there is this one time where none will exist, but in all the other cases, look, there's examples for all of them. So definitely maybe press pause and take some time to look over that. So let's do some examples now that you've had a chance to press pause and read all those. So here's your first example. I'm going to tell you that the arguments are deductive, and I just want you to tell me whether valid or invalid. And then it just says, note the relationship between your answer and the truth or falsity of the premises and conclusions. Okay, and then finally determine whether the argument is sound or unsound. So press pause, read through both of those. Let me know what you think. And here are your answers. All right, so the first one is invalid. It's unsound. It has false premise, but a true conclusion. The second one was valid, but it is unsound. One of the premises was false. So you might want to go back again and double check. Sometimes, and I'm not going to lie, you're going to have to read through these multiple times. So don't get upset. You might have to spend a lot of time going over and over and over these. There are strong arguments and there are weak arguments. So a strong inductive argument is an argument in which it is improbable for that conclusion to be false, given that all those premises are true. It's highly improbable. In such arguments, the conclusion does probably follow from those premises. Conversely, flip it. A weak inductive argument is an argument in which the conclusion does not follow probably from those premises, even though it claims it does. Okay, so strong versus weak. Okay, so strong inductive argument, improbable that the premises are true and the conclusion is false. Okay, so that just means they have a probability of 51% or greater that conclusion is going to be, that you're going to have that true premise and that false conclusion. A cogent argument. Okay, here's another word, cogent. A cogent argument is a strong inductive argument and it has all true premises. Okay, if either condition is missing, the argument is called uncogent. So in a cogent argument, the premises must not ignore relevant information that would make them untrue. So cogent and uncogent, those are words you're going to hear in logic as well. If you have a weak inductive argument, however, though, your conclusion probably doesn't follow from those premises, even if they're true. And again, because your book is wonderful, it has this lovely little chart in your book. So where you've got true and probably true conclusions, true premises, probably false conclusions. It's got strong and weak. And notice there's only one kind here that doesn't exist. So you're going to, again, have lots of options. So the only kind that doesn't exist is a strong argument that has a true premise and probably a false conclusion. That's the only one that doesn't exist. That would be weak, right? So that's the only one that doesn't exist. But the rest of these situations could all exist. So you might want to press pause, read through these, take a second to kind of digest them. All right, so just to sum up, cogent equals strong plus all true premises. For example, every previous U.S. president was older than 40. Therefore, probably, the next U.S. president will be older than 40. In fact, I think we've only had one president that was under the age of 40. It was John F. Kennedy. So, you know, we pretty good chance that you're going to get an older gentleman or an older woman as your president. All right, so here's some examples. For the first one, so there's two here. Please read through them. Press pause if you need to. We're going to talk about whether they're strong or weak. Notice those. We're going to note those relationships and then determine whether it's cogent or uncogent. So press pause, read through. All right, here we go. Here are your answers. The first one is weak, uncogent. It has true premise, but a probably false conclusion. And the second one is a strong argument. It's uncogent because it has a false premise and a probably false conclusion. And again, these can sometimes be tricky, so don't feel like if you don't get it right the first time that you're not. So let's try some more. So press pause, read through these. All right, let's see if your predictions are correct. The answers are, the first one is deductive and it's invalid. The second one is inductive and it is strong. So again, please just keep practicing. I know these can be difficult. All right, let's try some true-false. True-false are always good. I like those true-false questions. So we've got some true-false. 1 through 8. Actually, I think I have more than that. I have 1, 2, 3, 4, 5, 6, 7, 8, and then I've got a whole nother page. I've got 15 of them. So what I'm going to do is I'm going to give you a second to press pause so you can think about each of these statements, write it down, whether you think it's true or false, and then I will give you the answers at the end. So here's 1 through 8. All right, and here is 9 through 15. So press pause on these as well, write down your answers. And here we go. Here are your answers for all 15. Let's see how you did. In your textbook, there is also this nice little flow chart, which I found, which I thought was actually really nice. Statements are either true or false. Groups of statements are either arguments. It just kind of flows through evenly. Strong arguments can be cogent or uncogent. If it's weak, it's always uncogent. If they're invalid, they're always unsound. So I found this flowchart to be really, really helpful that your book had. I found another one online, which is pretty much the same information, just presented differently. So I found this one as well online that I thought was pretty good. A little inductive or deductive decision tree. So if you find any of these to be helpful, please, feel free. Make some notes, whatever works for you. Remember, in this class, we're all about, writing down that information, because I don't expect you to memorize everything for the tests. So please just keep practicing. Whatever tricks you need to make, then do whatever flowchart you need. It's all good. All right, and the last section in this week is going to be called, it's from section 1.5, called Argument Forms, and it's called Proving Invalidity. So this section is going to look at the validity or invalidity of those deductive arguments by looking at their argument form. So form is going to be a big thing. So we're going to talk about some different forms. Let's just jump right in. All right, so this is a process where you're going to take out the words and replace them with a letter. So every time you put the letter A, you're going to talk about, it's like if we're talking about apples, we're going to replace the word apple with the letter A. So, and you want to do this because very often words will have emotional meaning, and you don't want your emotions to get involved in this. You just want to see, do they fit the form? That's all we're asking. This is our first valid form of a categorical syllogism is all A are B. That has to be true. All B are C. That has to be true. Therefore, all A are C. That must also be true. Invalid would be if all A are B, all C are B, then all A are C. Notice the order. Notice how this side was A, B, B, C, and then A must be C. Notice here the order was wonky. A to B, the B should be here, right? These two should be flip-flopped. So this is invalid. So it's important to know valid forms versus invalid forms as well. All right, when you are creating a substitution instance, so let me give you an example. So all sporting events are engaging pastimes. So sporting events is A, engaging pastimes is B. So all baseball games are sporting events. So all C, baseball games are sporting events. Sporting events is A. Therefore, all baseball games are engaging pastimes. Okay, so if we were to just put this first statement first, all C are A, all A are B, therefore all C are B, then it would follow. So notice they don't give you these in the right order, so you can always rearrange them if you need to. But this one does follow that argument form, so it is valid. There's also something else you can do called the counterexample method. So if you just want to prove that an argument is wrong, all you have to do is supply one counterexample. So just substitute in anything where it doesn't work, and that will prove it's not valid, and that the given argument will also be invalid. So that's I love the counterexample method. That's one of my favorites. All right, so when you're working with these forms, number one, you have to isolate the form and get it into that symbolic form. And that's where a lot of people have a problem with step number two, where you have to construct the substitution, with the letters versus the words. So this will take a little practice. So there's this form. So this one above is this form, all A are B, right? So A would be migratory waterfowl, and B would be birds fly south for the winter. C is geese. All geese are migratory waterfowl. Therefore, all geese. So, got to construct the letter, take out the words, put in the letters. This one, we have to rearrange it because C and A, and then A to B. So this one should be first and this one should be second, but that's fine. And then C, R, B will follow. And again, like I said, you have to rearrange those. I kind of skipped ahead there a little bit. All right. There is a step-by-step method for proving an argument invalid by using a counterexample. So again, I hate when people just read. I know you guys can read. So I'm just going to ask you to press pause for a moment and read through this step by step. And then we'll move on. All right. So hopefully you've read it all. All right. Why are counterexample methods useful? I love it because you can prove invalidity very quickly. Now, you cannot use a counterexample method to prove validity, though, so be careful. All you can do is just shoot holes in someone else's argument with this, right? You can prove that it's not valid. So that's why I like it, because it's very, especially in a debate situation, very easy. All you have to do is provide one counterexample, and boom, their argument is invalid. Yay, you win. So this is used a lot in the legal field. So if you go into law, you're definitely going to talk a lot about counterexamples. And that kind of thing. Op-ed pages are very, you're always going to find at least one counterexample in any kind of letter to the editor. All right, so how does this work? Okay, so what it does is we prove an argument invalid by generating one example, just one, of a given argument with the true premises, but the conclusion is false. That's all you have to do. It's quite simple, but you have to really be quick on these because you have to really know what the subject you're talking about, which is why debates are very, very well researched. Before a student goes into do a debate competition, they're going to do a lot of research. So, all right, things to remember when you're working on this substitution where you're taking out the words. Words like all, no, some, are, not, if, then. These are all important words. Other words that are important are like either, or, both, and. These are all these little words are important. The big phrases where it's got the nouns and the, adjectives, that's what we're going to be replacing with the letters. Remember the word some means at least one. Very important. I have to have my statistics class. I have to tell them this too. Remember, some means at least one. And the opposite of at least one is none. These are things I constantly have to tell my statistics class. This technique is sometimes difficult at first. It will get easier as you practice, so please don't give up. But the more problems you do, the better it's going to be. So, and again, if you're struggling, don't be afraid to look online. There's so many websites online to help you. I just think about all the stuff I could have done in college if I had had access to YouTube. It would have been fabulous. All right, so let's try an example. So, use the counterexample method to prove the following categorical syllogisms invalid. Okay, so first thing you have to do is you have to take this and you have to put it in the symbolic form. Once you've done that, then all you have to do is create the same pattern with different words to prove and make sure that your conclusion is false. Okay, so we're going to walk through this one together. Okay, so some politicians, so they use P, some politicians are what? They're people who will stop at nothing to win an election. So we called that W. Okay, so that's the form of that first sentence. Okay, and second sentence, no people that are politicians who will stop at nothing, so no W's, okay, are true statements T. Hence, no politicians are true statements. So that's on the left, that is the symbolic version. Okay, so all you have to do is create. So I did one for you. So some animals are dogs. That's a true statement, right? No dogs are fish. Notice the W had to be the same in both. So no dogs are fish. That is a true statement. So it follows, using this argument, that no animals are fish. Well, we know that some animals are fish. So that is definitely a false. So we have created a counterexample to that syllogism. All right, so let's see if you could try one. Here we go. Press pause, see if you can write the form, and then see if you can come up with a counterexample. All right, so here was my form. All homeless people, H, who are panhandlers, P, are destitute individuals. So H, P, and D are my. Therefore, all homeless people, H, are destitute individuals. So I just came up. This was the one I gave you. You might have something completely different. It's totally fine. Mine was all humans who are female are women. Therefore, all humans are women, which is obviously not true. we have lots of humans that are men as well. So, all right. So that concludes section 1.5. I hope you had fun in chapter 1. Come back next week for chapter 3. Have a good one.